Hello and welcome to the second part of Lesson 9. Today we're going to be looking at piecewise functions. So in the last video we talked about absolute function and how those guys are different depending on what your x value is. Now piecewise functions do that as well, but they're a lot more dramatic. They're much different than a absolute value, because with absolute value, you can just set the function equal to 0. That'll tell you where the switch happens, and you don't really have to think about that while you're evaluating. Whereas with piecewise function, you need to be a lot more attentive. So let's go ahead and go over to here. So let's write a piecewise function. So piecewise functions, well, first of all, they're going to look very different. So anytime you see a curly brace like this, that usually means a piecewise function is about to be coming at you. So let's say we have 1 over x for x is less than, let's say x is less than 0. Let's say we have x squared for 0 is less than or equal to x is less than, let's say, 20. And let's say x plus, let's see, what would that be? So x plus 380, and we'll say that only happens when x is greater than or equal to 20. So what we're going to do here is I'm going to ask for a specific value with x plugged in, and we're going to use a function based on what that x value is. So if I ask for f of, let's say, 3, we have to check which one of these we're in. So 3 is not less than 0, so we're not going to use that function for this one. 3 is also not greater than or equal to 20, so we will not be using that one. 3 is between 0 and 20, so we're going to be using this function for f of 3, which means that we are going to be picking this guy, so that's x squared, so we're going to be using 3 squared. 3 squared is 9, so if I have a point on this chart, it's going to be at 3, 9. So this is the point I get from f of 3. And when I ask for f of 3, the answer I'm looking for is 9. So which function you pick is going to be based on what your x value is. And this is always your x value. So with that in mind, let's back up a little bit. I'm going to put another one on the board, and this time I want you to go ahead and pause the video and try to figure out for yourself what you think the answer is. So this time let's do purple. So let's say we got f of, let's say, 10. Let's do f of 10. So I'll go ahead and give you a second. Pause the video, give it a shot, try to see if you can't figure it out. And okay, that's probably enough time. So now, if you guessed that it is 100, or if you worked it out to get 100, you are correct, because x is between 0 and 20. Therefore, we would do 10 squared. 10 squared is 100. And there we go. So that would be the answer to that one. So, of course, if we had picked something like, let's say, and go ahead and pause the video and try to do this one as well. Say we do f of 100. So if we do f of 100, we're going to go ahead and use that one, because 100 is definitely bigger than 20. So 100 plus 38, that's going to be 480, or I'm sorry, not 38, 380. So 380 plus 100 is going to be, because we have 100 for x, so 100 plus 380 is going to be 480, so we're all good on that front. Now, there's 2 of these that I want to go over real quick before we move on to the graphing stuff, because graphing stuff is going to take some time. But before we do that, I want to look specifically at 2 that students tend to struggle with. So let's say I want to do f of 0, and let's say I want to do f of 20. Now, interesting thing here is not the answer. So with the way I've set this question up, the answers you're going to get are going to probably be not too much effect. Oh, no, wait, yeah, they will be affected. Never mind. So in this example, and in most examples, it is very important which function you pick. So in this one, we'd use 0. So that means we're either in that function or that function. We need to know which one it is. Now, spoiler alert, this one says or equal to 0. So when x is 0, we go with the one that is or equal to 0. So even if this was pointing the other way, so if this guy had had the underline, we would have, oh, yeah. So if this guy had had the underline, we would have used this function, but it doesn't. So this is the function we're going to use. So we're going to use 0. So 0 squared, so 0 times 0 is 0. That's how we know what that function's value is. Now, the same is true for 20. So we want to do x, some underline, and then 20. This is the function that does it. So it's going to be 20 plus 380. 20 plus 380 is going to be 400. So this is something to keep in mind when you're trying to evaluate a piecewise function, is if you're checking a number that happens to be on the board, make sure you know where the underline is so you know when to plug in that number specifically. So I'm going to go ahead and clear the board now. All right, let's jump back to the lecture. So we're back over here. So now we know how to evaluate a piecewise function. You know, you plug it into the function that your x value can meet the conditions for. Next up, we're going to move into graphing. Okay, so graphing is where a lot of people have a lot of problems with piecewise functions. So we're going to go back to the board, and we're going to look at why. So just like before, so a piecewise function is based on the x value that we use with it. So this time I'm only going to use 2. So let's say we have x squared for x is less than 5. Let's say we do x plus 3 for x is greater than or equal to 5. Okay, so that means we have one function that happens here and another function that happens here. So if I go to draw my chart, I get a breakup over 5. So x equals 5, we're going to say, is right about here. So x equals 5. So on the left side of the chart is where the x squared function goes. So we're doing this, and we keep going, we keep going. But then something unique happens when I hit the x equals 5 line. So this guy is not underlined at all. So when I hit that line, I actually don't have a point there. So I need to write a big ol' circle there to let people know that, hey, I'm not actually allowed to plug in 5, but if I could plug in 5, here's where it would go. Now, I don't draw any of the yellow function past 5 because I only get this function when x is less than 5. When x is greater than 5, I have to do the x plus 3 function. So let's see. So if I plugged in 5, 5 plus 3 would be like 8. So we'd be down here. And we would have that point because, again, it's underlined. So this point is going to be there. It's going to be filled in. And then we're just going to do a straight up x plus 3 function from there. So this means that for the function that's on the left side, I have drawn that function. And for the function that's on the right side, I have drawn that function. And I made extra sure that if there's an open... if there's no underline there, if it's not equals, that I leave that dot as an open hole. That is what's going to be happening whenever you graph some of these charts. So sometimes you're going to look at these charts, and you're going to see some open dots, you're going to see some closed dots. Those are always going to correspond with whether or not it is equal to that number there. And if you have 3 functions, it's basically the same thing, only instead of graphing on the left or right side, sometimes you're graphing between 2 lines. The same principle still holds. You're going to be graphing it up until you hit this dotted line, and then you're going to switch over to a different chart. And whether it's an open dot or closed dot entirely depends on whether or not it's underlined in the original function. So that is going to be how you graph a piecewise function. So don't freak out when you see some graphs. You know, you'll see some graph that looks like this. And then it does this all of a sudden. It goes woo, and this one's open. And this one's closed, and this one's closed, and then there's a there, and then it just goes, and then like 3 totally different functions that look insanely different. We have no idea like how the heck do we even, well, it's just a piecewise function. So there's just different functions in between those lines. So just be aware that that's going to happen. It might look weird. You might have to, look at a graph and go, well, what the heck is going on there? Well, it's just a piecewise function. So. Okay, so now we're going to go ahead and go back to the thing. I think that's everything for piecewise functions. Yeah, so, and here we have a piecewise function that we're looking at. And this one I want to talk about a little bit. I tend not to talk too much about these because I want to save them for the synchronous hours. But this is a nice example of where a piecewise function exists in real life. So tax brackets are a concept where basically if you make so much money, there's a percentage of your income that has to go to the IRS in order to pay your income tax. So the more money you make, the higher your income tax is going to be. And of course, these numbers aren't accurate to real life whatsoever. But the idea still holds that basically the higher the X value is, so the higher your income is, the higher the amount of tax you need to pay. So the higher percentage you're multiplying your income by. So this is a good example of a simple piecewise function in the sense that people go, oh, okay, so once you're above a certain value, it changes what kind of numbers we're looking at. That's usually an easier one to understand. So anyway, that is going to be the end of this video, and I hope you guys are having an awesome day, and I will see you later. Don't forget to try out the independent practice so that you can get a little more comfortable with piecewise functions. And I cannot recommend Desmos enough. If you look up Desmos piecewise functions, you'll probably find some good examples of piecewise functions people have made in Desmos, and also how that gets written in Desmos. So anyway, I'm going to leave you off for now. You have an awesome day. Bye-bye.